Okay, this is Geometry Lesson 8.3, Take 2. The first one was blurry, so hopefully this one's going to work. Okay, we are doing showing that a quadrilateral is a parallelogram. So we are going to use the properties to identify parallelograms. So again, for the theorems, I don't care that you remember the numbers of them, but I do need you to understand the ideas behind them. So if both pairs of opposite sides of a quadrilateral are congruent, that means the quadrilateral is a parallelogram. So if AB is congruent to CD and BC is congruent to AD, then it is a parallelogram. So next theorem, if both pair of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then it is a parallelogram. So if you look at example 1, in the diagram, AB and DC are adjustable supports, so the basketball hoop moves up and down, and they say, please explain why AD is always parallel to BC. Okay, so first of all, we have opposite sides are congruent, so that means we do have a parallelogram. So the side lengths are going to stay congruent even if the shape changes. So this will remain parallel to this because it's just going to be moving up and down, but the 36 and 36 will stay, the 18 and 18 will stay, and AD remains parallel to BC because of it being a parallelogram. Okay, so we're going to move on to the bottom two theorems. So again, numbers are not as important as the ideas. So if one pair of opposite sides, focusing again, just hoping that it works. If one pair of opposite sides of a quadrilateral are both congruent and parallel, so instead of both pairs, like up here it said both pair of sides and both pair of angles, here it says if one pair of sides are both congruent and parallel, then you have a parallelogram. So BC has to be parallel to AD and congruent to AD to make it a parallelogram. And then the last theorem on the page, if the diagonals of the quadrilateral bisect each other. And remember, we've talked about bisect. Bisect means if this is a bisect, it makes congruent pieces on both sides. So if the diagonals bisect and make this congruent to this and this congruent to that, it will be a parallelogram. So BD and AC have to bisect each other on the picture. Okay, page 2. Okay, example 2, the headlights of the car have the same shape as shown. Explain why you know B is congruent to D. Okay, we have one pair of sides that are both parallel and congruent, so that means we know it's a parallelogram based on our theorem. So BC is congruent to AD and BC is parallel to AD. And so if we know it's a parallelogram, opposite angles are congruent, so we know that angle B has to be congruent to angle D based on the properties of a parallelogram. Okay, example 3 in quadrilateral GHJK. So again, we're going to have to draw a picture. We walk around GHJK. If G is 55 and H is 125 and J is 55, what theorem can you use to show it's a parallelogram? So again, if it's a parallelogram, we know angles are going to be congruent if they're opposite. So if we look, 55 and 55 are congruent, so that means that angle H has to be congruent to angle K, so angle K has to be the 125 also. Okay, if we move on to example 4. Okay, for what value of x is each quadrilateral a parallelogram? Remember, diagonals bisect, so if this is congruent to this, This piece is also congruent to that piece. So we're just going to set up an algebra statement that 5x is equal to 2x plus 9. Subtract 2x. So 3x is equal to 9. So x is equal to 3. Okay, same thing going this way. This side has to be congruent to that side. So 4x minus 7 equals 2x. Please subtract the 4x. We're trying to get the x's on one side, numbers on the other. So minus 4x minus 7 is equal to negative 2. We divide by negative 2. So x is positive 3.5. Okay, if we take a look at the concept summary, ways to prove a quadrilateral is a parallelogram. Each one of these by themselves proves that you have a parallelogram. So if you find both pair of opposite sides are parallel, you have a parallelogram. If you show me that both pair of opposite sides are congruent, you have a parallelogram. If you show me both pair of opposite angles are congruent, you have a parallelogram. And if you show me one pair of opposite sides are both congruent and parallel, you have a parallelogram. And lastly, if you show me the diagonals bisect each other, then you have a parallelogram. So one of these by itself would prove it's a parallelogram. So if you look at example 5 at the bottom, it says show this quadrilateral is a parallelogram. We're going to draw in the diagonals, and we're going to prove that these two pieces are the same as those two pieces. So we're going to find the midpoint. So if you remember, midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So if we do Km and find its midpoint, it's going to be 2 plus 6 over 2 and 2 plus 0 over 2. So 8 over 2 and 2 over 2. So the midpoint of Km is at 4, 1. Okay, now we're going to try going, so that was going this way, now we're going to go this way. So Ln, again, same thing, x plus x over 2, y plus y over 2, and it's really 4 plus a negative 2. Okay, so 8 over 2, 2 over 2. So since the midpoint meets at 4, 1 on both of them, that means that this piece is congruent to that piece, and this piece is congruent to that piece, which, remember, if we show the diagonals bisect each other, proves that that's a parallelogram. So that's it on 8.3.